I don't have Dino on. Hold on. Yeah, I taught him how to use it. That's because you guys abuse it all the time in there. Okay, so plugging in 1, we end up with -2. What happens if we plug in a 2? We get a +2. What's the difference between these two? How much did it go up by? Didn't it go up by 4? Is there anything in the equation which might also hint to the idea that it would go up by 4? Well, sure. This is a linear function, y equals mx plus b. We talked about how the slope is the same thing as the common difference. I should say common. And that common difference in this particular case is 4. Now, I could continue plugging in 3, 4, 5. Right? Or another way I could handle this question was what we taught you. If we start with the first term at -2, and we know that we're adding 4, okay, you guys are annoying. We can continue adding 4 to find the remaining terms of 6, 10, and 14. This is an arithmetic sequence. Arithmetic means it goes up by a common difference, adding. So that's a way we could handle it as well. Or we could just plug in 3, 4, 5. As I said, everybody, sorry, give a second for you to copy that down if you need to. Then we got to go on. Question 2 we're skipping, so make sure to cross off question 2. Going to question 3. Write an explicit formula for the following sequence. Okay, now, are we adding or multiplying? That's the question. Add or multiply? Clearly we can see that we're adding. Now, if you want to find the common difference d, you take any term and you subtract the previous term. Now, I know that's not very difficult in this particular case. You can clearly see, 10 minus 9 is equal to 1. We are going up by 1 every single time. The formula for an arithmetic sequence is first term plus common difference times n minus 1. We wrote that a bunch in your notes. So, we literally need to come up with a few numbers here. Do we know the first term? There are, 1, 2, 3, 4, 5 of you that should be answering that question. Do we know the first term? Bullock, do you know what the first term is? What is it? You're looking up here. What's the first one? 9. Thank you very much. We already calculated the common difference to be 1. So literally, this is the only thing that would go on this line right here. Now, do you have to distribute the 1 and add like terms? No, you don't. You literally can leave it like that. Abbott, what do you think we should plug in to find the 10th term? Any thoughts? What should I plug in to find the 10th term? What should I put in here for n to find the 10th term? What do you think? Take a stab, come on. Alright, we'll pass it off. Alonzo Rangel, what do you think we should plug in for n to find the 10th term? How about a 10? Thank you very much. 9 plus 1. That's what you were going to say, Abbott, wasn't it? You were going to say 10, and you would have been correct. So we're literally just plugging that in. And, Rupert, what do we come up with? 18, thank you very much. Alright, flip over to the next page. Are we adding the same number every single time? To go from one term to the next. 1, 2, 4, 8. Are we adding the same number? Hopefully you would say no. Are we multiplying by the same number? Hopefully you would say yes. So, what is that common ratio? Well, the common ratio, we use the letter R for common ratio, is found by taking any term and dividing by the previous term. So in this case, I think I'm going to start with 2, and the one before it is a 1. So what is 2 divided by 1? Well, hopefully you know that's 2. So we are going to multiply by 2 every single time. The formula for this would be geometric then, because geometric goes with multiplication. So we would need the first term times r to the n minus 1 power. So, D and E and F are bad options. D and F for sure. And then this one's linear. And so is this one, by the way. This one's linear. None of those apply. We want geometric, so it's got to look like geometric. Do we know the first term? I mean, we know the multiplier is a 2. Do we know the first term? Well, look, you got this one? What's the first term? It is. Thank you very much. 1. Yep, you got it right there. So, out of your choices of A and B, which one looks like what we have right there? That is choice A. Thank you very much. Nina Marua, what are we going to plug in to find the 10th term? 10. Thank you very much. So, 1 parenthesis 2 to the 10 minus 1 power. Well, look, you got a calculator open for that? Okay. While you're doing that, we're all going to cross off number 5 and write skip next to it. Cross off number 5 and write skip next to it. Bullock, let me know whenever you got it. Yeah, get that Desmos calculator open and tight. Got it? What do you got? 512 is correct. Thank you very much. Skipping question 5. Please mark that. Next page. Also, skipping question 6 at the top of this page. Somebody in my first period asked me, does that mean it's not going to be on the test? I was like, yes, that's what that means. Okay. This question 1, find the missing term of the following. They tell me arithmetic sequence. We know that means we're adding. We have the first term. We are missing the second term. We have the third term. That's kind of the way we should view this. How many times are we adding the common difference to go from the first term to the third term? How many times? Abbott, what do you think? How many times am I adding? D. 2 times. Good. So we're starting at 6. We're adding 2 common differences, and we end up at 22. This is the equation you need to help me solve. So hopefully you would subtract 6, get 2D equals 16. Alonzo Rango, what would be my next move? Divide by 2. Excellent. So now we know that the common difference is 8. Okay, Rupert, what am I going to do with that 8 to find the one that I'm missing? What do I do with the 8 to find the one that I'm missing? Okay, she's passing. Ninu Marua, what do you think? Add the 8, right? So I start with 6, I add the common difference, and I get my missing term of 14. So just use the common difference to find the one we're missing. Question 2. Okay, are we adding or are... Oh, it says it's arithmetic, so we know we're adding. Okay, all right. So what's the common difference between the terms? Oh, no, it doesn't say it. It doesn't say they are. It's asking me if they are. Okay, so let's see if they are here. 17 minus 8, 26 minus 17, 35 minus 26. So I'm taking any term and subtracting the previous term, and I want to see if they all give me the same number. Because if they don't give me the same number, then my answer is going to be there is no common difference. So I can see that the first one's 9. Bullock, what do you got for the second one? And let's see here. Abbott, you do the third one. What do you got, Bullock? For 26 minus 17. Okay. And Abbott, what do you got for the last one? 9 also? Okay. All right. Hey, they're all the same, so that's a yes. And take a stab in the dark, Rupert. What you think the common difference is? Thank you very much. Alright, the next question. They want me to find the 120th term. So do I want to use that strategy where I'm doing this? Well, let's see. It starts out at a 9. What's the common difference between the terms? Can anybody tell me that? The common difference? We got any term minus the previous term. Looks like it's also 9. So is this the strategy you want me to do? Answer plus 9. So second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term. Is this what I want to do to get to the 120th term? No, that is not what I want to do. Thank you very much. I would like to use the explicit formula, first term common difference n minus 1 like this. We just need to plug in some numbers here. Alonzo Rangel, what's the first term? 9. Oh, I forgot my n value. My n value is 120. 120. I should have included that. This is a much more efficient way to do this question. Look what you end up with. Did you get 1080? Okay. Good. Now, when you're taking the test, it's a coincidence that these two numbers are the same. I mean, even in the next question, we could see that the first term is 36. This theater has 36 seats in the first row. Then it goes 38, then it goes 40. What's the common difference between the terms? What's the common difference between these terms? Common difference is 2. Any term minus the previous one. We're looking for the 18th row. First term plus common difference. 18 minus 1, because that's the row we're looking for. So clearly, not every time will these two numbers be the same. So in the previous example, that was just a very big coincidence. And if we type this out, Rupert, what'd you end up with? Should be under 75 somewhere. Should silence that. 70? Good. Yeah, if you got your notifications turned on, make sure you silence that. I don't think that was on my computer. Okay, in this particular question, they start out with the 16th term, and they tell me that that 16th term is negative 6. Then they tell me this information. The common difference is negative 3. What they're trying to tell me is, in order to move forward, add negative 3. Okay? So if they ask me for the 17th term, I am going to take negative 6 and add negative 3 and get negative 9. Did they ask me for the 17th term? Yes or no? No, they didn't ask me for the 17th term. They asked me for the 15th term. So I don't want to go forward. I want to go backward. How do I go backwards? If adding -3 is going forwards, what would I do to go backwards? Come on, don't make it harder than it is. What would you do to go backwards? Well, you could say subtract -3, but that's a fancy way of saying what? Adding 3, right? So, if I add +3, I will go backwards. So, Abbott, what would I get if I take -6 and I add 3 to go backwards? I would get -3. That's exactly right. So they asked me to go backwards, not forwards. On the next question, we're going to do the first part, but not the second part, so you can scratch that second part out only. I don't know whether we're multiplying or adding. If you think we're multiplying, that would be any term divided by the previous term, like 8 divided by 2, which would be the number 4. If we take 8 and we multiply it by 4, do we get 14? If we take 8 and multiply by 4, do we get 14? Yes or no? We do not. So my initial guess at geometric was wrong. So, not geometric. So now I'm going to check to see if we're adding. Okay? 8 minus 2. Well, that's obviously 6. If I take 8 and I add 6, do I get 14? Well, this is a winner. This is the strategy we needed. Okay? So, definitely arithmetic. So the arithmetic formula, we need the first term, we need the common difference. Those are the only two numbers I really need to find the formula. So, how's this going to start out? Alonzo Rangel, what do you think? 2 plus 6, and then parenthesis n minus 1, and we're done with the question. If you feel like you need to distribute the 6 and then add like terms, be my guest. It's not going to offend me if you don't. There's no reason you have to. Question 7. In an arithmetic sequence, we start with a term of -21, and the common difference is 3. They want to know which term is -3rd. I mean, is it the 10th term, the 20th term, the 50th term? That's what they want to know. So, we know the first term is -21. We know the common difference is 3. We do not know n. But we do know that they want to know which term is -3. So I put that on the other side of the equation. So I have to solve this equation right now. Let me give you a good first clue to get started on this. Move that -21 to the other side. So obviously that means I would be adding 21. So now my equation would say 18 equals 3 parenthesis n minus 1. Can you tell me what to do next? Rupert, what would be a good next step? Oh, that's a good idea. A lot of people would distribute, and there's nothing wrong if you decided to distribute, but Rupert had a good idea. What about we just divide by 3? That would get me 6 equals n minus 1. Bullock, what would that be? If I know that 6 is equal to n minus 1, what does n have to be? Well, 3 minus 1 is not 6. I'm just saying I want you to solve this equation right here. Well, 5 minus 1 is not 6. So I think you went the wrong direction. Wouldn't you have to add 1 to both sides? Because you want to get rid of that subtraction? Well, 18 over 3 is 6. That's where we got the 6 from. The 3's canceled out. So what would we get? You got that? What is 7? All right. It's the 7th term is what we're talking about. 7th term. Question 8, we're going to skip. Cross that one off. Next, decide if the following is geometric. Okay, geometric, that's multiplication. So we're going to try that. Any term divided by the previous term, and we ended up with 4. So if I take 8 and multiply by 4, do I get 32? Is 8 times 4 equal to 32? Yes, it is. So that is a definite yes. Okay, it is geometric. And the common ratio is 4. End of problem. Now, you could double check again, take the 32, multiply by 4, but yes, you do get 128. Find the 6th term of the geometric sequence. Now, there's 2 different ways we can handle this question. We know the first term, right? We can find the common ratio by taking any term and dividing by the previous term. So what is negative 15 divided by 5? Hopefully you can see that that is a negative 3. So we could do this. We could say if you want to find the 6th term, we'll plug in a 6 for n. First term times r to the 6 minus 1 power. This is one way that we can handle this question. And then, of course, we can reach over to our machine and we can type 5 parenthesis, negative 3 parenthesis, and then use the caret, raise it up, make sure either you're going to subtract 1 from and change that to a 5 on your own, or you're just going to type it with parentheses. We know the answer is negative 1,215, negative 1215. But I said that's not the only way we could do this. There is another way we could handle it besides using that formula. We could take the first term, which is 5, and put it and hit enter in our calculators. And then we could say times negative 3. So this would give us the second term, and then I could keep repeatedly hitting the enter button. Now, the reason I think this is a good strategy is because we're only looking for the 6th term. If we were looking for the 500th term, ain't no way I would be doing this. But 3rd term, 4th term, 5th term, 6th term, and we can see that it's negative 1215. So, Either strategy would work on this. Like I said, if you had a much bigger term you were looking for, you would definitely want to do it this way and then just change that number to whatever term you were looking for. Okay, so we have the first term. We do not have the second term. And we have the third term is 6. They tell me it's geometric, so that means we're multiplying. However, I don't know what r is. Now, how many times do I multiply by r to go from the first to the third? How many times am I multiplying by r? No, I wouldn't multiply 4 times. I would do 1 time to find the missing one, and 1 time to find the third one. So it's only 2 times. Okay? So we're starting with 24, and we're multiplying by r twice. Now, how do we say multiply by r twice? My first period class said 24, believe it or not. I'm hoping you would say r squared. And then we land at 6. If I take 24 and I multiply by r twice, I land at 6. So this is the equation I need to solve. What should we do first? Abbott, you got an idea? How should I solve this? Yep, that's a great idea. Let's start with division. So that would give me r squared, and 6 over 24 reduces to 1/4. Now, some of you would get a decimal on your calculator. You would have r squared equals 0.25, and there's nothing wrong with that if that's what you do. How do you get r by itself? What's the opposite of squaring something? What's the opposite of squaring something? Square root. So, no matter which one of these you're doing, you would get 1/2, right? Because you do square root of 1, square root of 4. Or your calculator, if you do the decimal version, will give you 0.5. I don't care which one you use. How do I find the missing term? How do I use this 0.5 or 1/2 to find the missing term? What do I do to the 24? Any idea? Yeah, multiply. 24 times 1/2. So what's 1/2 of 24? 12. Yep. The missing term is 12. That was the one that was missing in the middle. So, use the ratio to find missing term. Okay. A couple more questions and we're done. Next page. Now, letter choice D on that one was a really bad fake answer. Okay. We know this is geometric because they give me an r value of 0.2. That means the ratio is 0.2. We know that our formula a sub n is equal to a sub 1 times r to the n minus 1 power. Now, can we all agree that letter choice A is a bad one because they told me that the first term was 0.2 and we can clearly see that the first term is 625. So hopefully you can cross that one off right there. And out of your 2 remaining choices, B or C, which one is correct? Hopefully you see that C is the only one that's correct. I really hope that you don't miss the first term since I gave it to you at 625. And then if you want to find other terms, you could use the strategy we just talked about a minute ago. Enter the first term times 0.2, enter, 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 and that gives me the remaining terms, 125, 25, 5, and 1. So you literally can let the calculator just figure out those numbers for you. There is one last question I'd like to look at, which is, we're going to skip this question, so we've done enough of those. That's an easy question, by the way. So, if that shows up, you're just adding 5 every time, so it would be arithmetic. And so you could say, oh, that's 30 and that's 35, because the common difference was 5, so that one was an easy one. This one is geometric. You're looking for the salary after the 4th year. We know that you're starting out with $36,000 the first year. They tell me that we're increasing by 10%, which also they tell me right here that I'm multiplying by 1.1. So they gave me the multiplier. Now, I would probably use the same strategy we just used a second ago, starting with 36,000. Multiply by 1.1, because then you could have the second term and the third term and the fourth term, and you would have your answer at 47,916. That's a bell. We got bells back? Boy, I didn't realize that.